This is part 3 of the pre-calculus notes for Essential Skill B3, Part 1, Sketching Polynomial Graphs. When we left off, I asked you to think about examples 7 and 8 and see if you could come up with a way that this would be possible. The answer to both questions is yes, and I'll show you how. A third-degree polynomial with no multiplicities can have 3 direction changes. And so, if we have a third-degree polynomial whose direction changes are above the x-axis, we only have one intercept. Similarly, a fourth-degree polynomial can go in 4 different directions, up, down, up, down. So, a fourth-degree polynomial could look like this. 1 direction, 2 directions, 3 directions, 4 directions. Now on to our final topic, identifying the polynomial. This is basically going backwards. We're given a sketch and we're going to identify what polynomial created that sketch. We have one more piece of information, though, that can go into one of these equations. Notice that these have zeros of -2, 1, and 3. -2, 1, and 3. But the difference in the equations is that one of them has a constant multiplier out front, like a vertical stretch and flip. This has nothing, or an implied 1. So knowing the zeros isn't quite enough to get the complete equation. We need to find this constant multiplier. We typically use the variable a to represent the constant multiplier. This is consistent with the a that we've seen in graphing transformations as a vertical stretch. When we're finding an equation, we need to consider that there may be a constant multiplier. In fact, there will be. I'll show you how to set that up in just a moment. When we're presented with a graph, the first thing we're going to do is identify the zeros and their multiplicities. The zeros are the x-intercepts. So there's a 0 at x equals -1. And the graph passes right through that 0. That is a linear factor that has a multiplicity of 1. And so our exponent will be 1 when we set up the equation. We have 2 other zeros, one at 2, one at 4. Notice that the graph bounces like a parabola at each of these zeros. So those are both going to have multiplicity of 2. These let us create our factored form equation. Notice we need a placeholder for the constant multiplier. We don't know what it will be. X minus -1, x minus 2, here's our multiplicity, x minus 4, also with multiplicity. We have one piece of information that we haven't used yet. There's a point that we're given on the graph. That's how we're going to solve for a. We're going to plug in 1 for x, 3 for y, and then solve for a. Having solved for a, we can write the answer now.